Welcome to my 2020 MuleSoft Hackathon submission. My name is Jason Estevan and I'm the world's hardest working MuleSoft developer/architect. Based in Toronto, I work as an independent consultant or contractor for organizations that use MuleSoft across the US and Canada. I also help to represent MuleSoft, a Salesforce company, as one of their community ambassadors. Bestowed this great honor mainly for my YouTube channel that has many MuleSoft tutorials on it, but also for a bunch of talks I've given on the technology. The 2020 MuleSoft Hackathon is a perfect reason to try and solve a problem the Estevan family deals with on a daily basis. Living in Canada, we experience 4 extremely different weather seasons. Temperatures can range from minus 40 degrees in the winter to 45 degrees Celsius or 110 Fahrenheit in the summer. This regularly shouldn't be a problem in itself, as our home is programmed to always be the same temperatures indoors. However, the way our heating and cooling system is set up in our home, the temperature in each room can differ dramatically. Our home has what is called central heating. One big furnace blows hot air using duct pipes throughout our whole house. When on, the whole house heats up. In summer, it is the same process, but the air conditioner creates cold air to blow through the same pipe system. Whether the system is on or off is determined by a thermostat that takes the temperature of the room it's in, compares it to a program setting, and determines whether it needs to be warmer or cooler in the house. And that is the flaw in the whole system. The thermostat is taking the temperature of our living room, which changes dramatically based on whether the curtains are open, if someone is cooking in the kitchen, and other things like lights, electronics, and people around. So the temperature in our living room determines whether the heating and cooling system should warm up or cool all the other rooms in our home, including the ones upstairs. On this floor, the heating is most important. It is where all our bedrooms are. This can make sleeping very uncomfortable, especially for our 2-year-old. He isn't old enough to be able to use a blanket. Quite often he wakes up crying because his room is too hot or too cold. If the temperature in the living room, the floor underneath us, is cool, then the furnace will turn on, pumping air into his room. At his age, he can't do anything about it, and he ends up with bad sleep, waking up soaked with sweat all over his shirt and hair. Our family needs a heating and cooling system that measures the temperature of the rooms that are most important in our home. Both of these products are by a company called SensorPush. Their small device measures humidity and temperature. These readings get stored either in the device or transferred to your phone if you have the mobile app installed, which we are currently downloading now. The app also lets you see all the temperature readings this device has taken with nice fancy graphs. The downside is, in order to see these readings in real time, your phone has to be close enough to the device so that Bluetooth can connect and transfer those readings over. That is why I purchased that second device, which is the Wi-Fi gateway. This will also connect to the humidity and temperature sensor through Bluetooth. However, it will automatically connect to your Wi-Fi system and send those values up to the SensorPush cloud. And the big bonus is, now that those values are up in the cloud, we can use SensorPush's APIs to pull the data and create our own customized application. After everything has been set up, temperature and humidity readings will now start coming in. However, since we just set up, there are no readings to display. So we're going to move this sensor device from my office into my son's room. I'll put it in a place that he shouldn't be able to reach. However, the measurements won't be affected by anything else in the room. Don't worry, that light is an LCD, so it doesn't emit any heat. Let me take the cover off the air vent so we can get an accurate reading without all the hacks we've been using before. We're going to wait now and let the device start collecting measurements. So it's been a few days since we first set up our devices, so we should have plenty of data now inside the SensorPush cloud. We can access it using their website, sensorpush.com, and logging in with the account we had to create on setup. Once in, they can show us the sensors that we have installed, called Bedroom 1, and then our gateway that is uploading that data into their cloud, which was a minute ago, so we know it's working. And now we can go to the graph to see some historical data. So these are the readings for the past week. The top level is the temperature and the bottom is the humidity. You can see the green bar is when we started taking measurements for the first time. So for the past couple days, the bedroom has had a high temperature of around 26 degrees Celsius and a low peak right down here at 22.6. Not sure what happened. So we're having about 3.5 degrees between the top and the bottom. And this just goes to show you how ineffective it is to have the thermostat in the living room to control the temperature in a bedroom upstairs. Before seeing this, I would assume that the temperature readings would be more of what we have in the middle of the graph here, which is a tightly bound highs and lows that are only maybe 1 degree apart to show you that when the furnace turns on, the temperature goes up, and then when it turns off, it goes down. However, I am quite surprised to see these really high peaks and these really low valleys. This must be one of those cases where something that was happening in our living room that inversely affects the temperature in the bedroom upstairs. So the first thing we need to do in order to improve this is to get our hands on the data points. And SensorPush has APIs that allow us to do just that. What I like to do whenever I start an API integration is create a minimal viable product. You can learn more about why I do this in a previous video I created that I'll link to above called The List of Biggest Mistakes MuleSoft Developers Make. So I create the minimal viable product using an application such as Postman. So what I've done in Postman is create all the outbound HTTP requests that my Mule application will make. So I have 3 requests: my authorization, my OAuth access, and then I query my data samples. And you can see I have all 3 created here. Now running through these one at a time will get me a feel of how my application is supposed to function and catch any gotchas before I get too deep into writing Mule code and then I lose time by having to redo everything. And lucky that I did, because a few things popped out at me right away. The first thing I noticed that all the endpoints that SensorPush provides are post requests, even though I'm fetching information. That tells me that they're not following the REST standard to a T, so I need to be careful not to make too many assumptions when I'm building my requests, as well as the data format on the way back. And here's another example. The W3 standard is actually a capital A on accept, so I just gotta make this adjustment to make sure that I get JSON data back. So back to my step 1, my authorization. I put in my user credentials and I get back my authorization token. The second step they tell me to do is to generate my access token. In the API document, they talked about this is my OAuth access call, and all the URLs have OAuth in it. If this is indeed OAuth, there's some massive steps missing. There was no registration on my app with the SensorPush API service. I never was given a client ID or secret. When I generate this, there's no refresh token. And the authorization request in the previous step used my actual sign-in to the website. But anyways, we can still work on this. It's just great to find out these things first before you get into MuleSoft code, because now knowing this, I know that I cannot use the OAuth module in my MuleSoft flow, and instead I actually have to use the HTTP request module and make these authorization API calls individually. So after I generate my access token, I take it and I put it into my query as a header. And the API will return the time the sample was taking, the temperature, and the humidity. I don't want to keep saying how important it is to create this minimal viable product first. It's all in the video. But again, I now just found out that samples are taken roughly a minute and a half from each other, which is information I didn't have before. As a developer or architect, you can now start to envision how you want your flow to look like. Some of the choices you'll have to make is if you have a scheduled job, how often is it going to run? We know that readings are every a minute to a minute and a half, so that'll come into play. To prevent against maybe one bad reading, we're probably going to want to take a few of them to get more reliable numbers. And lastly, what comes to mind is that the limit parameter that they give us just gives us the last 20 readings. But how do we know that those were current? If this system has been down for an hour, the last 20 readings may be from an hour ago. So the first decision I want to make right now is maybe limit is not the best way to query samples. Let's instead use the parameter start time. This allows us to get all readings from a certain time period forward to the present time. So if I get all readings from over an hour ago, I know at least that they're current. One thing I did just notice is that we got exactly 20 samples back when we asked for 20. Might be a little bit of a coincidence, but I wonder if we're not getting every sample taken from this time. So let me see if I try 25. Yeah, we actually got 25 back. So we are missing some samples. So if we decide that our application is going to use time as the metric of how to pull samples back, let's just give this an arbitrary number that we'll never reach. Wow, we did miss a lot of samples. There was 48 of them. So now I think we're ready to get started coding. We're inside our Anypoint Studio, and today we're going to be working with Studio version 7.6.0 and the Mule Runtime 4.3.0 Enterprise Edition. The goal of our flow is to connect to the SensorPush APIs and query the measurements that we're pulling from our bedroom. The trigger for this flow I've set up is a scheduler that I've set to 10 minutes. From our Postman calls, we realize that samples are pulled every 1 to minute and a half, so I think 10 is a good number. It'll get us maybe around 8 to 9 samples. I'm storing the timestamp in UTC because that was one of the requirements on the query API. And then I just have a logger that's saying that we're starting our pull. And I'm using our timestamp as kind of a correlation ID. So when this application is running for days on end, you can kind of see what information came from what run. The next 3 API requests, again, is creating our supposed OAuth authentication with SensorPush. So our sign-in was using my login username and password. I've abstracted these out into a configuration properties just to be cleaner. And then this generates our access token, and then I can make our queries for the samples. I'm choosing a really high limit that we're never going to use. And then instead of using the current timestamp because there will be no values, what I am doing is backing up 10 minutes from the current time. So the idea is that this program will run every 10 minutes and pull the time, all the measurements from the previous 10 minutes up to the present time of samples. I've added quick choice just on the number of samples I get returned, just to make sure that the sensor is working and then we got measurements from the past 10 minutes. And if not, I just print out a warning message that just says no samples found, again using our correlation ID. Now it's time to execute on the results. So what I'm doing is 4 different calculations. The first one is to calculate the average temperature. So I'm taking all the temperature readings that we have pulled and using the data we've averaged function and then rounding it to only 1 decimal place. Same thing with humidity. Take all the humidity readings for the past 10 minutes, average them out, and then round them to 1 decimal place. I also thought it might be valuable to take the max reading of all the temperatures that we have. So again, just using a simple max data weave function, and then the min as well. And lastly, now that I have all my calculations in variables, I just have a logger that prints them all out. So I have my correlation ID, print out what my average temperature is, average humidity, my max temperature, and my min temperature. And that's it. Let's go ahead and run it and see what happens. So my first logger prints out my UTC time that this job is running at. And then I do my sign in, which should get me my authorization token. I do my access, which gets me my access token. I query my sample. So in my payload now I have all my measurements. So you see observed temperature, humidity, observed temperature, humidity. So if I look at the bottom, it gave me 6 samples. So I get into the top choice because I actually have samples. And now out of those 6, I start getting the averages and the min and max, which are now stored in these variables. And now I just make one summary log statement. Sample calculations, average temperature was 73.8, average humidity 70.8, and the top measurement was 73.8, and 73.8 was the min. So at this point I have an accurate reading of the temperature in that upper bedroom. So the next question is what I do with this information. And for that answer, you're going to have to wait to the next video. If you have any guesses, leave them in a comment below. All I say is that I'll use the power of MuleSoft. Until then, I'll see you next time. Peace.